Good day everyone, I'm Maureen Pilas from ESN Math TV. Now we will talk about geothermal and hydropower energy. Let us first talk about geothermal energy. From the word geo means earth and thermal means heat. So we will talk about heat of the earth. Our planet of Earth has a 5.9742 times 10 raised to 24 kilogram mass. And it has 509.6 million kilometers square surface area. It has also 148 million kilometers squared land area. And the thickness of the Earth's mantle is 2,900 kilometers, as we can see here in our picture. And it has 2,200 kilometer thick in outer core. So this is the outer core, and it has 1,200 kilometer thick in inner core. So this is our inner core. The lithosphere here has 75 kilometer deep to base, and its continental crust is 35 kilometer deep to base, and the ocean crust is 7 kilometer deep to base. So we can see now the structure of our planet Earth. It has a lithosphere, mantle, outer core, and inner core. So lithosphere, here it is the crust, and top of the mantle are separated by the Mohorovesic discontinuity. The continuity sits on huge tectonic plates which have moved over geological time. Next one is the Earth's mantle. The mantle is composed of semi-solid silicates of magnesium and iron. It moves slowly by convection. There are separate circulations in the upper and lower mantle. Next one is the outer core. It has 4,000 degrees Celsius and composed of molten iron and nickel. The outer core is fluid. Its rapid circulation and the electric currents within it create Earth's magnetic field. The next one is the inner core. The inner core is solid, possibly made up of crystalline iron and nickel. Its temperature is around 6,300 degrees Celsius. But the innermost pressure of the rock above it stops it melting. As what I've said a while ago, geothermal is heat of the earth. So geothermal energy now is the earth's natural heat captured in reservoirs of fluid saturated rocks at depths ranging from a few hundred meters to over 3,000 meters. In most areas on earth, the heat source magma or molten rocks lies too deep for its energy to be useful here and there. However, the magma has worked closer to the surface, slowly transmitting heat to the layers of fluid saturated rocks above. Where this heated fluid penetrates the Earth's surface, we see such phenomena as hot springs, geysers, or fumaroles, whips of steam rising from cracks in the ground. Manifestations like this indicate to Earth scientists that an area may have geothermal potential. So the geological conditions necessary to produce a geothermal resource exist in a few parts of the world. The Earth's crust is made up of large plates which are relative. The areas with geothermal energy potential are most likely to be found along the boundaries of these plates, most often along the Pacific Rim. So here is the example. We can see the location of geothermal energy along the ring of fire zone of Pacific volcanoes. In California's Infernal Valley, the plates are moving apart. Here, the thinning of the crush allows the magma to move close to the surface. In other areas, such as the Philippines, the plates are colliding with one another, causing the development of magma at relatively shallow depths. Collisions can cause plates to stretch and shatter. In the geyser region of Northern California, the fracturing and coating of the continental plate have allowed the magma to migrate closer to the surface. So the geothermal resource may be in the form of dry steam or hot water, depending on the conditions which exist within the underground reservoir. This energy can be tapped by draining wells into the productive zones, as it is done for oil and natural gas, thus bringing the steam or hot water to the surface. So there are different types of geothermal resources. It requires different types of production systems. If the resource is air dry, steam, or vapor dominated reservoir, droplets of the condensed steam and tiny rock particles are first removed in a separate core. The resulting clean steam is then piped directly to an electrical generating plant, where it turns a turbine in the same fashion as the steam produced in a boiler heated by burning oil or coal. The same function as the steam produced in a boiler heated by burning oil or coal. If the resource is hot water or liquid granulated reservoir, the heat energy can be extracted into ways. The first is called the flash method. The fluid surface as a mixture of hot water and steam. Pressure is reduced in a flash vessel which separates the steam from the hot water and allows more of the fluid to vaporize or press into steam. This steam can be employed as if it were natural dry steam. The unflashed hot water is returned to the reservoir through injection wells. The second type of hot water production system is the Brayford turbine method or binary cycle. Geothermal hot water is brought to the surface and contained in a closed system under pressure as is the original temperature and its liquid condition. This geothermal fluid is then pumped through heat exchangers. Here the heat gasifies a separate working fluid circulating in a closed system which is used to drive a turbine. After yielding the heat, the geothermal fluids are returned to the underground reservoir. Here is the diagram showing the tapping of geothermal energy. So this is the production wheel, this is the separator, and this is the receiver, then it is the scrubber, then this is the turbine, then generator, then control regulation or utilization, then here is the cooling tower, then this is the discharge tank. So the heat of most geothermal systems is normally well above the boiling point in the range of 149 to 315 degrees Celsius. For efficient use of this energy, electrical generating plants must be located within the geothermal field. This avoids the excessive heat and pressure losses that occur if the resource is transported by lengthy pipelines. Scientists at the United States Geological Survey estimated the electrical energy recoverable from high-temperature geothermal system in the USA over a 30-year period is about 23 million kilowatts on energy, equivalent to about 800,000 barrels of imported crude oil per day. A generating capacity of this magnitude would result in foreign exchange savings of over $5 billion annually. So, the Geothermal Development Project. Geothermal developments make major contributions to the local tax base as well as the general economy. They place small demands on public services and do not impose changes on the lifestyle of a community. Other significant consideration is that geothermal energy developed has minimal impact on the environment. Meanwhile, precious oil and natural gas supplies can be saved for higher value uses such as transportation, fuels, and petrochemical feedstocks. Yonhap is the world's largest producer of geothermal energy. The company supplies natural steam to power more than 1.5 million kilowatts of electrical generating capacity in the USA and the Philippines. For more than 25 years, it has pioneered new technology in drilling, production, and reservoir engineering and has spearheaded the cost-effective development of geothermal resources. The Philippines has two major geothermal areas in Makiling, Banahaw, and Tiri on the island of Luzon. The Makiling-Banahaw project is located in Laguna Province, so it has 55 kilometers south of Manila. A total of 330,000 kilowatts of generating capacity is supplied by Yonhap well at this project. So here is the Tiwi Albay geothermal plant. At the Tiwi project located in the Albay province south of Manila, Yonhap supplies steam to electrical plants with a total capacity of 330,000 kilowatts. Here is the Makiling-Banahaw geothermal plant. The Philippines is now the world's second largest producer of geothermal energy. Continued evaluation of the resource could lead to an increase in production. The use of geothermal energy in the country has significantly reduced its dependence upon expensive foreign oil exports. The geothermal energy powering every 110,000 kilowatts of generating capacity represents a crude oil equivalent of about 1.5 million barrels per year. Geothermal energy is a cheaper power source than comparable fossil fuel or nuclear power plants. Only hydroelectric power is less expensive. So the other uses of geothermal energy is geothermal energy can be put to direct uses at lower temperatures for batting or their oldest use, warming buildings, growing plants, processing food, and even fish farming. Another technology called the geothermal heat pump or GHP uses the near constant temperature of the earth just below the surface to heat and cooling buildings. Direct uses and GHPs has no polluting emissions, and GHPs can be used anywhere as they do not depend on the hydrothermal aquifer. Next one is hydropower energy. Hydropower or water power converts the force of flowing water, usually from an elevated source, into electricity. Flowing water has been used during the past centuries for winding cane and running textile mills. In the early 2001 century, hydropower supplied 40% of the United States electricity. Today, it's power about 10% of the nation's electricity. The most common type of hydropower plant is an impoundment reservoir, which requires the constructions of a dam to create an abrupt draft from which water falls a specific height or distance to free-flowing water below. When the water is released, energy from the flowing water drives the turbine blades and simultaneously drives an alternator or generator to generate electricity. Hydropower is an inexpensive way to generate electricity and produces no air pollution. However, hydropower facilities are expensive to build and have a significant impact on water quality and wildlife habitat. When a dam is constructed, a large tract of land is covered with water. Ang Buklao electric power plant is one of the dams constructed in Luzon for the purpose of generating electricity, and another one is in Benga Electric. Next one is in Caliraya Hydroelectric Plant and the Maria Cristina Falls. In Mindanao, the Maria Cristina Falls also generate electricity to some nearby provinces of Lanao del Norte. The three hydroelectric plants in Luzon supply most of the electric power requirements of northern and central Luzon and the National Capital Region. Ocean tides are another possible source of power. A dam across the mouth of River Wanch in France, built in 1966, has a series of sluices and water turbines. When the tide is coming in, the sluices are open and the flow of water upstream turns the turbines to generate electricity. At high tide, the sluices are closed, trapping the tidal water behind the dam. After the tide has ebbed, the sluices are open and the outflowing water again turns the turbines, which are reversible. So here it is. The Larance Dam in Bretagne, France, houses a tidal power plant, and it produces 240 megawatts of electric power and can generate electricity on both the EVV or ebb and flow of the tide. So that's all. Thank you, and my other group will continue the report. God bless you all.